Hello everyone, in today's video we are going to talk about logarithm property. So in the last video we talked about the property of log, such as you have the inverse property, which is log base b of b to the x is equals to x. Also b to the log base b to the x also equals to the x. And then exponential property, whereas log base b 8 to the r power is equals to r. You can pull out exponential as a coefficient of the whole log base b of 8. So remember that this is different than log base b a to the r power. These two is not equal. For the first one, it's taking the whole log and raised to the r power. The second one is just raised to the a to r power. So the exponential property only works for the second one. All right, so the next one is change of base. With this one, it can help us to use a calculator to calculate the value of the log. So the log b of a, if they have the same base, it can be written as log base c of a over log base c of b. And the application of that is, for calculator, we can put in this one or the natural log. All right. So while this property allows us to solve a large number problem, but they're not sufficient to solve all of the problem involving the exponential and logarithm equation. So today we're going to learn another property of a log will help us to solve the exponential and logarithm equation. Okay, so the next one is the sum of logs property, which is log base b a plus log base b of c equals to log base b a times c. Multiplication, so that means addition become multiplication. Remember that this is not equals to, okay, log base b of a times c is not equals to log a plus log base b of c. This is not distribution. This doesn't work in that way. Okay? All right, so if we have the sum of log, that means we also have the differences of log, which is the log base b of a minus log base b of c is going to equals to, make a guess, division a over c. So remember that the addition become multiplication and subtraction become division. Okay, so now let's look at some examples. How can you, with this property, I can ask you to rewrite the log as a large log. So if I want to write this as a single log, or these operations can merge the log together, so the first thing you need to check is, do they have the same base? They all have the base of 3, so that means, yes, these 3 terms, they can merge into a single log. So I have a log. Addition become multiplication. So this is multiply by a, subtract log base 3 of 2. So 5 times 8 is 40. And then subtract log base 3 of 2. And then subtraction will become division. So after they merge into a single log, this is going to become log base 3 of 20. Okay, another example is I have 2 times log 5 plus log to the 4th. So this is the common log, right? Which is the base is 10. All right, so the first one is I want to write it as the same log. So this one, they have a 2. Well, I can put the 2 as the exponential of the 5. So that means I have 5 squared log to the 4. And then addition will become multiplication. I have a log 5 squared, which is 25, multiply 4. So I have a log 10 and 200. So this is equal to what? Well, if I write this log 10 squared, because 100 is equal to 10 squared. So I know that, okay, by the inverse property, this is equal to 2. Okay, so this is called merge the large log, multiple terms of a log together. Another way to do it is expand the log, such as I want you to expand a single log as many log. So s to the 4 y. So for this one, I have ln s to the 4th times y divided by 7. So as sum or differences of log, when I rewrite this, I have ln s to the 4th multiplication s times s to the 4th times y. I can write it as s to the 4th plus ln y, and then divided by 7. We know that division can become subtraction. So I have it divided by ln of 7. But this is not done. By the exponential property, I know that I can put this in front. I have 4 times ln x plus ln y minus ln 7. So that will be the expansion of the log. Or we can use that to solve a logarithm function, such as log 2x minus 6 equals to 3. And to solve for x, we need to get it out of the inside of the logarithm function. So there are 2 ways we can approach this. First is rewrite this as an exponential function. So in this case, the base is 10, right? This is common log. The base is 10, and then these 2 swap. So I have 10 to the 3rd is equal to 2x minus 6. And then I can solve for x, which is 1000 at 6 equals to 2x. Divided by 2 on both sides, I have 503 equals to x. So that would be our solution, divided 2 by both sides. Another one is exponentiate both sides. What's that mean? So if, let me write this down, exponentiate both sides. So think about that. If a equals to b, then 10 to the a equals to 10 to the b. P power, right? Because a is equal to b. Think about that. If, for example, 10, a is equal to 0.4, b is equal to 4 over 10th, they're equal, right? So that means if I raise them to the same base, exponentiate that, 5 to the 0.4 power should equal to 5 to the 4 over 10th power. So that is that mean. So if that's the case, if we're using that idea, since we have log one side, this is a common log of 2x minus 6 equals to 3. So that means we can raise them or exponentiate them together. So how do I choose the exponential base? Well, since this is a common log, I will choose 10 as my base. The reason I do that is because later I can apply the inverse property of the log. So now, first step, let's exponentiate both sides. I have a 10 to the log to the 2x minus 6 equals to 10 times 3. And the right side by the inverse property, which is, we write it here earlier, this one. Base b log base b of x is equals to x. So in here, that means this part is going to equals to 2x minus 6 because this common law, the base of the common law is 10. So that means the left side of the equation equals 2x minus 6, and then right side is equal to 1000, right? 10 to the cubic function is 1000, and then you add 6 on both sides. I have 2x equals to 1006, and then divided by 2, I have 503. So no matter which way you use, you should get to the same answer. So now let's solve another example, such as common log 50x plus 25 minus common log x equals to 2. So in order to rewrite this in an exponential form, we need a single logarithm expression to the left side of the equation. So we need to merge these two terms together. So by using the differences property of log, we can rewrite it as a division, right? And subtraction, I can write it as division. So this is equal to 2. Okay, so again, you can use the way that we have two ways to do it. Either you would write the exponential form function or expansionate it on both sides. But be careful, this is a common log, so that means when you exponentiate that, you want to use 10 so that you can apply the inverse property. Okay, so this one, I'm going to write it as a exponential function, which is use the method 1. 10 times, I swap these two, square equals to 50x plus 25 over x. Now that I will have 100 equals to 50x plus 25 times x. And now I multiply x on both sides. I will have 100x equals to 50x plus 25. Now merge the like terms. I subtract 50x on both sides. I have 50x equals to 25, and then divided by 50 on both sides, so I have 1/2. So x is equals to 1/2. Okay, now take a look at this one. We've been using lots of common law. Let's look at natural log. Okay, so how do I solve these? Since they are natural log, we can use the sum of log property on the right. So this is multiplication. When I merge them together, I will have, this is addition. When I merge them together, I get multiplication. Okay, so think about that. We talked about, hey, if a equals to b, so that means 10 to the a power is going to equal to 10 to the b power. Can I apply the same thing for logarithm function? The reason is yes, because if you think about it, ln a is equal to ln b. So that means if everything is the same, that means a has to be equals to b. Well, in this case, I have x plus 2 times x plus 1 equals to 4x plus 14. if you can see this right away, you can use exponentiate both sides to get the same result. So, which is our second method. We have in here exponentiate both sides. So now let's try this one. You can see the answer right away. So in this one, how do you choose the base? Well, again, since this is a natural log, you want to choose the base the same, which is I raise exponentiate both sides on e. So the base should be e. Now I can apply the property of logarithm function, which is these I can put in front and they should cancel. So I will have x plus 2 times x plus 1, the inverse property of a logarithm function. I have a 4x plus 14, which is exactly what we have in here. And now we can solve it. First of all, you need to FOIL it. On this side, I have x squared plus 3x plus 2 equals to 4x plus 14. Now I need to merge the like terms. When I merge it, I have an x squared minus x minus 12 equals to 0. Use AC method to factor it. So I got x minus 4 times x plus 3 equals to 0. So when I solve it, I have x equals to 4 or x equals to negative 3. So now, please check your answer with a calculator for the original function and see what do you get. Well, if you check it, you substitute that into the original function, either one of these, ln x plus 2 or ln s plus 1 or ln 4s plus 14. Let's use the simplest one, check it in ln x plus 1 and see what happens. So if I ln x plus 1, the x substitute with negative 3, I will get ln negative 2. Well, if you put it into the function, you might notice that into a calculator, I'm sorry, if you put a negative number into a calculator, they will say, hey, this is Edward in the calculator, which means undefined. That means the calculator cannot calculate a negative number in the logarithm function. Why is that? Because this is what we're going to talk about. In a logarithm function, the domain of a logarithm function should be 0 to infinity. So that means we have to drop this because this is undefined. So that means we only have one solution, x equals to 4. Well, I will talk more about this domain in the last video. Right now, let's just focus on the calculations. So take a look at this example. It's an application problem. In 2008, the population of Kenya was approximately 13.8 million and was growing by 2.64% each year, while the population of Sudan was approximately 41.3 million and growing by 2.24% each year. If these trends continue, when will be the population of Kenya matches that of Sudan? So now let's look. So this is an exponential growth function. So let's write down their model for both countries. So for Kenya, I know that, hey, the output population, let's use K stand for Kenya and time to the time. T stands for the time. For the Kenya, it's going to be the initial value 13.8 times 1 plus 2.64%, and then to the t power. Let's convert this to a decimal. That will be easy for us to calculate it later. So for Sudan, the model should be The initial value is 41.3 million, and the growth rate is 1 plus 0.0224 to the t power. And if the trends continue, when would be the population Kenya matches the population of Sudan? So that means when these two equal, that means Kenya catch up with Sudan's population. So when these two equal, I have the function is 13.8 times 1 plus this number, which is 1.0264 to the t power equals to 41.3 times 1.0224 to the t power. Okay, so in this case, how can I solve for t? So if you see the unknown variable is in the exponential, your first thought is, okay, this is going to be a logarithm function. So how can I make a logarithm function in here? Well, the first step is you want to merge all the exponential form together, which means, okay, this is the coefficient, right? So let's divide it, either move all the exponential on the left side or the right side. So that means either way, it doesn't matter. You can either divide 13.8 or divide it 41.3 on both sides. And here I'm going to divide by 13.8 on both sides. So I got 1.0264 to the t power equals to 41.3 over 13.8 times 1.0224 to the t power. Okay, so, and then you want to merge all of the exponential with the variable, with the unknown variable terms on one side. So that means I want to merge these to the left side. What do I do? Well, you can divide it the whole number on both sides. Okay, so that means this one got cancelled. So that means the function is going to become 1.0246 over 1.0224 to the t power equals to 41.3 over 13.8. All right, so now the next step is, think about it. How can I combine these together? Well, I know that if I have a 2 over 5 square, this is equal to 2 square over 5 square. And if I'm doing the other way around, also true. So that means I can rewrite this fraction as 1.0264 over 1.0224 to the t power is equal to 41.3, 13.8. Okay, after I've done this, now I can solve for t, because I can convert this into a logarithm function, right? So when I convert this into logarithm function, I know that the left side of the exponential, this is the base, right? So that means, and when you convert it to a logarithm function, this is also be the base of the log. So your base is going to be 1.0264 over 1.0224, and you swap these two. The input become output, the output become input. So that means the function is 41.3 over 13.8 is going to equal to t. And then you just need to put in a calculator to solve this log. Well, when you put in a calculator, you can use the change base property to do that. Now I'm going to use ln. So when you put in the calculator, it should be ln 41.3 over 13.8 divided by ln 1.0264 over 1.0224 equals to t. Okay, now I'm going to use a calculator to calculate that for you. So this one is just a basic Google calculator. If you type in calculator, that is the first result that you see on Google. So in here, I have log, natural log or common log, they're both okay. So let's stick to common log. So natural log, I have 14.3 divided by 13.8. That would be the top of our fraction divided by the other one, ln 1.0264 divided by 1.0224. So this is equals to 15.99. So we round it up. So t is equal to 16. So that means after 16 years, the population of Kenya is going to match the population in Sudan. All right, so that's it for today's lecture on how to use this property to solve a logarithm function. Let me know if you have other questions. See you in the next video.